Hello guys, this is Prime Concept. In this video, we want to consider complex number, which we have already started. I want to look at how to write complex numbers in polar form. Now, of course, we have the standard form of complex number, which is what we started this video with. The standard form is also known as Cartesian form, which deals with x and y representation. But then we want to consider the polar form of representation of complex number, so which is very simple. Now, you'd recall that we drew a diagram which we called Argand diagram, and we said let if this axis, which is our x-axis, we call this x, and then we call this y, and this is going to be theta, or the argument, right? So that this place becomes the magnitude or the modulus of the complex number, which sometimes we can call r. Now, the standard form of representing complex number is z equals x plus I y. This is the standard or Cartesian form, but we want to consider the polar form. How do we represent complex numbers in polar form? So quickly, if we look at this, you'll see that from our SOHCAHTOA, this is a triangle, and then I want to get cosine of this angle. Cos theta, cos is adjacent over hypotenuse. Adjacent is x over hypotenuse, which I will be using r. So that if I make x the subject, I will get that x is equal to r cos theta. And if I do the same thing to find sine theta, sine of this angle is going to be the opposite, which is y over the hypo. So the opposite is y over r. If I make y again the subject formula, I'll find that y becomes r sine theta. Now what I'm going to do is to quickly replace x with r cos theta, and then I'll replace y with r sine theta, so that I'll see z becomes, instead of x, I'll then write r cos theta plus I. This is I. Instead of y, I'll then write r sine theta, so that you notice that something is in common, which is r. So if I factorize r, I'll be left in this bracket with cos theta plus I sine theta, which becomes z. So that what we have actually gotten is what we know as what? The polar form of complex number. So if you're asked to write a complex number in polar form, what you simply do is to use z equals r into cos theta plus I sine theta. So that is how you can write a complex number in polar form. But of course, this is not the only polar form we have, because polar form is a form that uses the magnitude r and the argument theta. That is what we refer to as polar form of complex number. So it means another form, another polar form. If you recall from Euler gave us a relationship for complex number, which in one of our videos we're going to prove Euler's relationship. According to Euler's relation, you have that exponential I theta, where I is a complex operator. Exponential I theta can be written as cos theta plus I sine theta. So according to Euler, this relationship is true. So if that is the case, it means that we can still say that z is equal to r. Now, instead of writing this, I would know that it is same as exponential I theta. So this is also known as polar form of complex number. So when we talk about polar form, this is polar form, this is also polar form, and then finally the third polar form we have is z equals r at an angle of theta. So this is also polar form. So there are three forms that are known as polar form, which is this, and also this. So three of them are actually known as polar form for complex number. Now, how do we put complex numbers in polar form? We're going to use just these relations to solve for this. I'll be giving two formulas that are necessary, because for you to write a complex number in polar form, you need to find r, which is the magnitude, and you need to find the argument, theta. So it means we'll be needing this relation r equals square root of x squared plus y squared. This is r. And then we'll be needing the relation which I will be calling alpha, which is equal to tan inverse of the absolute value of y divided by the absolute value of x. I'll be calling this relation alpha, so that we can then determine the different quadrants for which this would fall. We're going to see different ways of solving this. But first, since we are calling this alpha, it means we'll be interested in working with different quadrants. So for our circle, this is first quadrant. So in this first quadrant, alpha is equal to theta. So whatever we get for alpha using this formula is same thing as our theta. So that is what we'll directly put into this formula. Then when we're in second quadrant, our alpha is simply going to be, or our theta rather, because what we need to be able to put in polar form is theta. But the formula we have is the formula for alpha. So we have seen that in first quadrant, alpha and theta are the same. But in the second quadrant, theta is simply going to be 180 minus alpha, 180 minus alpha, whatever we get for alpha. Then in our third quadrant, which is this, theta is simply going to be, so what we have here is this, we have this, so theta is going to be 180 plus alpha. So that is what we have as theta here. Then in our fourth quadrant, theta is simply going to be 360 minus alpha. So that is what we're going to have there. So with this diagram, we should be able to write a complex number in polar form. So let's see a quick example on how to do this. Let's see a quick example on how to solve this. So I'll leave this diagram so it will be helpful to us. This is just one method, after which we're going to see the second way, because we can have different possible angles that will give us same relationship. So an example, write z equals 1 minus I in polar form. So we want to change this to polar form. And the first thing we want to identify is the value of x. The value of x is the real part, which is 1. The value of y is the imaginary part, which is negative 1. So I want to find r. R is the square root of 1 squared plus minus 1 squared. So that r becomes the square root of 1 plus 1, which is 2. So it means my r is root 2. The next thing I want to find is alpha. So alpha is going to be tan inverse of the absolute value of y. Remember, absolute value means your y should always be positive, your x should always be positive. The absolute value of y is going to be 1, divided by absolute value of x is going to be 1. So this is simply going to give me tan inverse of 1, so that alpha becomes the tan inverse of 1, which is 45 degrees. So I've gotten my alpha. Now, secondly, I want to ask myself, or thirdly, I want to ask myself, which quadrant does this complex number fall? So x is positive, and then y is negative. Positive x, negative y falls in what quadrant? The fourth quadrant. So, and in my fourth quadrant, to find theta is simply going to be 360 minus alpha, so minus 45 degrees. So if I do this subtraction, I'm removing 40 from this, I'll have 20. If I remove 5, I have 15. I have 315 degrees is my theta. So for me to write this in polar form now, I'm going to simply say that z is equal to r into cos theta plus I sine what? Theta. So this is what I have, so that I can then write my answer z to be r, which is what? Root 2 into cos theta, which is 315 plus I sine what? 315. So this is my answer. So I've been able to write this complex number in polar form. Now I want to also inform you that it is possible that you finish solving, say you're writing an exam, a JAMB exam, you're writing a SAT exam that is objective, you may not find this in the option. So there are different possibilities that would give the same result. So this is one approach for this. I'm quickly going to explain the second approach for solving this same question so that we can see the other possibility for this. Now, the second possibility for solving this problem is considering the sine of the angle. Considering the sine of the angle. So for the second way, let's call it method 2. So the second method for solving in polar form is to use the formula z equals r into, this time around, cos alpha not theta plus I sine alpha not theta. So this is the second way for solving this. Recall that alpha is equal to tan inverse of the absolute value of y divided by the absolute value of x. So this is another way to solve it using alpha and not using theta. But one of the things you want to consider when you are using alpha is to, you note, in this method, you consider the sine of the trig function in the quadrant. You consider the sine of the trig function in that quadrant. Now let me explain this also to you. Now I'm not repeating the process where I'm solving the same problem. We've gotten our first answer. Now using method 2, what would our answer be? Method 2 says you should use cos alpha and this. Now, I know that this complex number lies in what quadrant? It lies in the fourth quadrant, like we have seen. And if you remember your cast, in our fourth quadrant, only cosine is positive, sine is negative. So what it means is that if I want to write my answer using this formula, I'm going to consider that cos is positive in the fourth quadrant, but sine is what? Negative. So I'm going to include that in my answer. So my answer, my second possible answer is r, which is root 2 into cos is positive, so I would maintain cos alpha, and my alpha I got to be 45 degree. 45. Then sine in the fourth quadrant is negative, so I'm going to change this to negative. So it becomes negative I sine 45 degree. So, and this becomes my answer. This answer is correct as much as this answer is also what? Correct. How do you verify that these two answers are correct? Simple. Just use your calculator, evaluate cos 315, evaluate sine 315, and multiply out by this. If it gives you this exact result, it means that this answer is correct, which is obviously correct. Same thing, how to verify this? Evaluate cos 45, evaluate sine 45, multiply out. If it gives you this exact result, it means that the two answers are correct. So this answer is correct as much as this answer is also what? Correct. So this is how you can write a complex number in polar form. In my next video, I'll take more examples that will help you understand this. If you have enjoyed this video, quickly hit the like button. You are yet to subscribe, hit the subscribe button, drop a comment, share this video with your friends. Tell them it is prime concept. Thanks for watching.